Hello everyone, welcome to my channel. Today I am going to discuss about Coulomb's law. So this is one of the most important laws of electrostatics. But before that, let me revisit what I had taught in the previous class. So we had all learned about charge. What is charge? Charge is the intrinsic property of a substance, and we know the charges are now of two types: positive and negative. Okay, and what is the SI unit of charge? The SI unit of charge is Coulomb. It is denoted by capital C. And what is the CGS unit of charge? It is stat coulomb. It is denoted by STAT in capital C. So these two are the units of charge. Now, what is the relation between Coulomb and stat coulomb? So 1C equals to 3 into 10 to the power 9 stat C. Okay, so you remember this, 1 coulomb equals to 3 into 10 to the power 9 stat coulomb. Now, so this charge, whether it be positive or negative, so charges can develop forces of attraction or repulsion between each other. Suppose this is charge Q1 and we take another charge Q2. Let both be positive. Now these two charges will develop mutual attraction or repulsion based on their polarity. What is the meaning of polarity? Means whether they are positive or negative. Okay. So what did Coulomb state? Coulomb stated that according to him, two stationary point charges Q1 and Q2 either repel or attract each other, with a force F, which is directly proportional to the product of the magnitude of the charges. Okay, product of the magnitude of the charges, and inversely proportional to the square of the distance between them. So if R is the distance between them, so it will be inversely proportional to the square of this distance. Now, one thing that you have to remember that these two charges Q1 and Q2 are stationary point charges. What is the meaning of stationary? Stationary means at rest. So before only it was told that this electrostatics deals with charges at rest. So these two charges are not moving. Okay, and another thing that you should keep in mind, that this should be point charges. Now what is the meaning of point charges? Point charges means that suppose you take a charge, suppose you consider this charge only. So this charge, if its dimension is, suppose its radius is r prime. Okay, so now r prime should be very, very smaller than r, that is the distance between these two charges. That is, it is very tiny compared to the distance between them, and hence it looks like a point compared to the distance between these two charges. Okay, so this is the meaning of point charge. So Coulomb's law is valid for point charges only. So now if you if we remove this proportionality sign, what will happen? So let's see. So if F is the Coulombic force Q1, Q2, and it is inversely proportional to R square, then if we combine combine 1 and 2. So combining what we shall get? Proportional to Q1 Q2 by R square. So now you know that if you have to remove this proportionality sign, you have to bring here to, if you want to remove it with an equal to sign, then here one constant will come where K is a constant. Okay, so K is a constant known as electrostatic force constant. Okay, electrostatic force constant. So K is a constant known as electrostatic force constant. Now, what is the value of K? So you should think, what is the value of K? So K's value is 1. So K can be written, K's value is 1 by 4 pi epsilon naught in vacuum. Okay, and what is this value? And the value of K is, this total thing has value 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of K. And what is this term known as? This term is known as epsilon naught. Not for this, and otherwise this term is known as epsilon. It has a value 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. Okay, so now you may think, how did this unit come? How does this unit come? So there you can understand, if it is F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square, which is the Coulomb's law. If you want to find out this term, we can write 1 by 4 pi epsilon naught F into R square divided by Q1 Q2. Okay, so now what you can write, if F is in Newton, R is in meter square, and this is in Coulomb square. So you can write its unit as Newton meter square per Coulomb square. So in this way this unit comes. Okay, so this was all about the constants. So now you can understand that now since these are two positive charges, so the net force between them will be, so this one will exert repulsive force on the other, and same here. So this was about Coulombic force. So what is the formula of Coulomb then? Coulombic force 1 by 4 pi epsilon naught Q1 Q2 by R square. This is in vacuum. Okay, so now suppose this was in vacuum. Now suppose if you take the value of A in some other medium. Other medium means, suppose you keep two charges inside any other material apart from vacuum. So suppose if you write M here. Okay, so how can you write this? So it will become now this. So here we see only epsilon comes. Here it was epsilon naught, here epsilon comes in place of in any other medium. So this you have to remember. So now if you take the ratio of this two, suppose if you take if you do 1 divided by 2, what will you get? F by Fm. F by Fm equals to, so all the things will get mutually cancelled out, and only what will remain? Epsilon by epsilon naught. Okay, so now this ratio, it was found out that this ratio is equal to K. Okay, where K is dielectric constant, where K is dielectric constant or relative permeability. Okay, or we can write that, or we can write K equals to, sorry, or K or epsilon equals to K into epsilon naught. You have to remember this formula, very important for numericals, for short answer questions, very important. So what is the value of K? K's value is greater than 1 for all dielectrics. What are dielectrics? Dielectrics are materials where the electrons are tightly bound to the nucleus. Okay, so for all dielectrics, K's value equals to 1 for vacuum. Okay, K's value equals to 1 for vacuum. K equals to 80 in water. Okay, in air its value is 1.00054. So that is almost approximately equal to 1 only. So you have to remember this two for 1 and therefore we can write that, therefore the in a medium the force becomes 1 by K times of force in vacuum. Okay, that is, if some dielectric is taken in between the charges, then the force between them decreases by a factor 1 by K. Okay, so by a factor of K it decreases. Okay, so you have to remember this. So it decreases by a factor K. Okay, so now what is the relation between, what is the comparison between Coulomb's law and gravitational law? So let us see what is the similarities and dissimilarities between Coulomb's law and gravitational law. So we know that Coulomb's law, we write it with F subscript C, 1 by 4 pi epsilon naught Q1 Q2 by R square, and here also if you see G into M1 M2 by R square. So there are some similarities. Similarity is that both are inverse square law. Both are inverse square laws. That means both are inversely proportional to the square of the distance between the two bodies. In case of charge, we have to take two charges Q1 and Q2, and in case of gravitational force, we have to take two bodies M1 and M2. So both are inverse square laws. Another thing, so this was the similarity. Okay, so what is the dissimilarity? Dissimilarity is that electric force, so electric force is either attractive or repulsive. Okay, and gravitational force is always attractive. Gravitational force is always attractive. Next, it depends on the medium. It depends on the medium, does not depend on medium. So this you saw that when we took a factor when we change the medium, the Coulombic force decreased by a factor of K. So but it does not happen in case of gravitational force, whether you take it inside water or whether you take it in space or wherever you take the gravitational force between two bodies, does not depend on the medium. F will remain the same if the two bodies are same. Okay, no matter where you take the bodies. Okay, so this was the difference. So these two are sufficient for you. So you can remember these two. These two are the most easiest ones. And you can remember another one is that electrostatic forces are much stronger. This one you can remember that electrostatic forces are much stronger. Okay, much stronger than not as strong. So this thing you can remember. That's all. So now let's see what is the vector form of Coulomb's law. Okay, and also remember what are the limitations of Coulomb's law. First of all, point charges and rest charge. There should be rest charges and point charges. Okay. So what is the vector form of Coulomb's law? Vector form, suppose these are two charges, Q1 and Q2, and let R be the distance between them. Now what will be the force on charge Q1 due to Q2? So Q12 will be, sorry, 12 will be 1 by 4 pi epsilon naught Q1 Q2 by R square. Now let us put a vector sign. So now if we put a vector sign, so in the left hand side we have put a vector sign, so in the right hand side also you should put a vector sign. Okay, in the right hand side also you should put something vector. So here what we can do, we can take a unit vector and what will be the direction of this vector? So suppose let us take a unit vector in this direction. So this, let it be named this, and let it be named R21, R21. So now force on 1 due to charge Q will be in this direction. Okay, it will repel this charge towards this side. It will repel this charge towards this side. And now force on charge Q2 due to this will repel this side. But you see this force is in which direction? Is in this direction towards the left, and then left direction is signified by this unit vector R21. So here we will write R21. So we have to remember that you have to represent this direction by writing something here. Okay, so here we are writing the unit vector to denote the direction of this force. And this unit vector doesn't change the magnitude of this thing. It only signifies the direction in which this force is pointing. So now similarly, force on charge Q2 due to Q1 can be written as f of 21 vector 1 by 4 pi epsilon naught Q1 Q2 by R square. R square will be same because the distance is R. So it will be R12. Why? Because you see here now this force will apply a force on here and it will repel this charge towards this side. So the force is pointing this side. Now this force is pointing this side. So a vector which is pointing this side is R12. So R12 is the unit vector which is pointing this side. Okay. So the direction is in this manner. So what is the importance? So here you can see that in the importance, you can see that this R21 is equal to R negative of R12 and f of 21 vector is opposite of f. Okay, so this shows that these two vectors are equal and opposite direction. That means you can say here that another law is obeyed here. So that is Newton's third law. So Newton's third law is obeyed here because these two are equal in magnitude. So you see this total thing is same in both the cases. Only the unit vectors are different and these notations are different, but these are unit vector. Magnitude is 1. It is only signifying the direction of the force. So these two are of equal magnitude, but these are in opposite directions. So Newton's third law is obeyed. And another thing you have to remember, these two forces, if this is the charge, okay, so the forces are always acting towards the line joining the charges, okay, that is, it is along the line joining the charge. It is not acting along this direction, this direction, this direction. It is acting along the line joining the centers. So electrostatic force is a central force, okay, so electrostatic force is a central force, we can say. So this was all about Coulomb's law. So now today's final topic is the principle of superposition. So what is principle of superposition? So principle of superposition states that if you consider a charge here, another charge here, another charge here, okay, so if you take these charges and then the net force on any one charge equals the vector sum of the forces exerted on it by all other charges. Suppose you take the force on charge Q1 due to the charges this one and this one. So these two charges will individually apply a force on this charge. So what will happen? That the resultant force, so the resultant force on this charge can be taken as force on charge 1 due to charge Q2 and force on charge Q1 due to charge Q3. So and then you can write the formula also, like 1 by 4 pi epsilon Q1 Q2 by you can write the unit vector like 1 by 4 pi epsilon naught, okay, Q1 Q2 by R12 square, and you can also write the direction R12 unit vector plus 1 by 4 pi epsilon naught Q1 Q3 by R13 square R13 unit vector, okay. So you can write it in this manner. And suppose if you have a number of charges, so you can keep on adding. If there is a number of charges, so you can write it as 1 4 plus dot 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 plus, okay. Suppose if there are two charges only, so you can also apply this formula, root over f1 square plus f2 square plus 2 f1 f2 cos theta. Whenever suppose there is charge q1 q2, okay, suppose this is 1 2 1 3, so 1 2 1 3, okay. So net force is suppose along this direction, and this is the theta, the angle between the angle between these two charges, okay. You can also find it in this manner. So that's all for today. So this was all about Coulomb's law and principle of superposition. Thank you.